Hi everyone, I am Nirisha, Assistant Professor in the Department of CSIT working in MLR Institution of Technology. Today we are going to discuss about loop control statements in C. Coming to the overview, we are going to learn about while loop, for loop and also the do while loop. So consider a situation in which we execute a single statement or block of statement repeatedly for the required number of times. So at that time we are using repetition statements. We are also calling it as iterations and also calling it as repetition statements and also calling it as looping statements. And say, for example, assume a situation where we want to print a message for 100 times. If you want to perform this task, we need to write 100 printf message statements to print 100 times in a single printf statement. So this is a complex task. So the same task can be performed very easily by using the looping statements. The looping statements are used to execute a single statement or block of statements repeatedly until the given condition is false. Suppose when we go with a real-time example, if you want to take a cash from an ATM machine. So if I'm in that ATM machine, the limit is only of 10,000, but you want an amount of 40,000 in a case, consider. So at that time, you will take the cash of 10,000 and that the same process you will repeat for 4 times, for almost the 4 times. So it is nothing but the same steps you are repeating until we complete our task. So the same thing we are going to solve by using the looping control statements. So here for looping control statements, there are some 3 kind of loop statements, that is while statement, do while statement and also the for statement. So all these 3 are used for looping statements or iteration statements. So all these statements are called as looping statements or iteration statements or repetition statements. So all the 3 words mean the same. All are used for repeating the statements until we finish our task. So coming to the while loop. So the syntax of the while loop is, here we are writing the while and the next we are writing the condition. Whatever the statements that you want to repeat, that we are writing in this block of statements. In an open and closing brackets, we are writing the statements. If this condition is true, then the set of statements, the block of statements will get executed. So this block will get repeated until our condition is false. So if it is true for n number of times, these set of statements will get executed. And if the condition is false, then at that time we are coming out of this block. And this is the flow chart or flow diagram of a while. So here we are writing the condition, and if this condition is true, the block of statements will get executed and again it will go and check the condition here. So when we are going to come out of this repetition at the time when the condition is false, then at that time we are out of the loop statement. And what are the next statements after the repetition statement? Those statements are getting executed. So this is the functionality of the while loop. And one of the example program, here we are finding an example program to print the sum of individual digits of a given number. So here we are trying to print the sum of individual digits of a given number. For suppose my number is considered some 123. So in that 123, I want this is the input that I am giving and this is the logic that I am writing inside the while, and I want the output as 1 plus 2 plus 3, that is equals to 6. So the input I am giving it as n value as 123 and the output I need to get it as 6. It's nothing but the sum of individual digits we are taking and we are adding to each other and we are finding the sum of those individual digits of the given number. So for that, inside the main function, we are taking the integer variable like n, remainder and sum is equals to 0. N is to store the input value and remainder and sum are used to store some of the values that are required in our program. And next statement is a scanf statement. We are reading the n value. Without any n value, we cannot find any kind of sum of individual digits. So for array problem statement, for sure we need to require input, logic and also the output. So input we are reading by using a scanf statement and output we are printing by using a printf statement. And then next, inside the while loop we are setting the condition, and based on this condition we are given the statements inside this while. Based on our task, we have given the statements inside the while. And how we need to set the condition after completion of our task, the condition should get terminated. In such a way, we need to give the condition. So we have given the condition as n greater than 0. So check for 123, is 123 greater than 0? Yes, it is greater. So we have taken the output as the input number as 564. So 5 for 564, we'll find it out. So 564 greater than 0. So in the condition, we have written n greater than 0. So whatever the input that we have given, that will be stored in the n, in the address of the n value. So here we have given n greater than 0. So 567 is greater than 0. Yes, the condition is true. So if it is true, what we are finding? The first step, we are finding the remainder. So coming to the remainder is equals to n modulus 10. That is 564 modulus 10. If we divide this 564 by 10, it goes 56 times and 560, and here the remainder we have got it as 4. Here we are using a modulus operator, so this is going to give the result as the remainder. So here the value of this 5 modulus 10 will be equals to 4. If you are using modulus operator, we'll get the remainder as a result, and if you are using division operator, we'll get the quotient as a result, as we discussed in the operators. So here we are finding the first step as remainder, and the next step, that is sum is equals to sum plus a remainder. So initially we are taking sum is equals to 0. So 0 plus remainder that we have got is 4. That is equals to 4. And this plus equals to is a shorthand operator. So that is equals to sum is equals to sum plus a remainder. So this is almost equivalent to, the statement is almost equivalent to sum is equals to sum plus a remainder. And the next step is n is equals to n by 10. So if we divide this 564 by 10, we'll get the quotient as 56. So in this way, we are getting the, by calculating the remainder, we are getting the each of the individual digit out from the given number, and that number we are adding to the sum variable, and then next we are reducing that number to get the individual digits of the other digits. So this is the first iteration. This will come under first iteration, and coming to the second iteration. So again, we are checking again, after completion of the statements, it will go and check the condition over here. So again, now the n is greater than 0. The condition is n greater than 0. Here n value is 56. So 56 greater than 0. Yes, 56 is greater than 0. So if it is true, again what we are doing, again we are finding the remainder. So remainder is equals to, if we divide that 56 by 4. So if we divide that remainder with, if you are dividing that 56 by 10, it will go for 5 times 50s, and we'll get the remainder as a 6. So here the remainder that we got now is a 6. And the next step is sum is equals to sum plus remainder. So sum is equals to sum. Previous sum that we have got is 4. And now that the remainder that we have is 6. So 4 plus 6 will be equals to 10. And in the next step that we have, n is equals to n by 10. So if we divide this 56 by 10, we'll get the quotient as 5. So now the n value is 5. So coming to the third iteration. So third iteration, what will happen again after completion of this statements, again we'll go and check the condition here. So the condition here we have given as n greater than 0. Here n is 5. The n value we have got is 5. So 5 greater than 0, yes, it is true. Again we are finding the remainder. So remainder is equals to n modulus 10. So 5, if we divide the 5 by 10, so it cannot go. So 5 is larger. So in the third iteration, 5 greater than n greater than 5, that is 5 greater than 0. So that is true. 5 is greater than 0. So the next step, if the condition is true, the first statement that we need to execute is, we need to find the remainder by using the modulus operator. So if we divide this 5 by 10, so we cannot divide this 5 by 10. So we cannot use any decimal point values because we are using the data type here as integer. So we are not considering any kind of float values. So we are not using any kind of point values in the quotient. So it never goes. So we are taking it as, we are multiplying it with zeros. So we'll get the remainder here as 5. So the remainder after this step, that is 5 modulus 10, we'll get the answer as, the remainder here we got it as 5. So the remainder is 5. And in the next step, sum is equals to sum plus remainder. The previous sum that we got as 10. So 10 plus 5, that is equals to 15, and n is equals to n by 10. If we divide this 5 by 10, we'll get the quotient as 0. So here we are done with all the 3 digits. So now we need to terminate our loop. So that is the reason why we have given the condition as n greater than 0, or n not equals to 0 also works. So with this condition, so that is the reason why we have returned the condition as n greater than 0. After getting the n as 0, the statement should get stopped. So we have got the sum, that is sum of all the individual digits, as 15. So here 5 plus 6 plus 4 will get the answer as 15. And the next, after the n is equals to 0, again we'll check the condition here. 0 greater than 0, the condition is false. So if the condition is false, we are coming out of this loop, and the next statement is printf, print that sum value. So what is the sum value that we have got? That is 15. So the 15 will be displayed in this place of this control string place. So in this way, we should give the input, and also we need to write the logic based on our task, and also we need to give the output. So, and that the repetition statements, we need to set the condition in such a way that after the completion of our task, the condition should get false, and we need to come out of that loop. So this is the test cases, and also whatever the number you have given, so by using this code, you will get the sum of individual digits. Whatever the n value you have given, for all the n values, you will get the sum of individual digits. So this was done by using a while loop. So this is nothing but repetition statements. We are repeating our statements until we complete our task. So next is a for loop. So for is also same as a while, but we have a syntax differences. So here the syntax for is for initialization, condition, and modification. In for we have some 3 sections, whereas in while we have only 1 section, that is the condition section. But coming to the file, we have some 3 sections. We need to initialize that value, and we need to write the condition, and also we need to do the modifications of that initializations values. So if this condition is true, whatever the block of statements that you have given, that will get executed. So this is a flow diagram of the for. Here we are initializing the value, and coming to the next, we are checking the condition. If it is true, then this loop statements will get executed, and if it is false, where it is coming out of this loop and going to check the next statement. So while and for are called as entry controlled loops. So after checking the condition, then only we are going to enter into the block of statements, and those statements what we have given, that will get executed. So one of the example program for a for. So here the example program is to find whether the number is a prime or not. So to find the number is prime or not, this is the logic that we are using. This is the program, and here in the main function we are taking these variables n, I, and count is equals to 0. N is to take the input, and I is used for a loop variable, and count variable we are using whether we have got some factors or not. So in the next, by using this kind of statement, we are reading the n. So as we all know the concept of the prime numbers. So if that number is divisible by any other number from 1 to 1 or itself, as we know the concept of prime numbers, so for a prime number, it should not get divisible by any other number except 1 and itself. So that is the concept of a prime. So here how we are finding whether the number is a prime or not. So for example, take the number as 5. So this number that we are dividing by 2, and that the same number we are dividing by 3, and the same number that we are dividing by 4, the same number we are dividing by 5, and also the 1. Here we are not considering as 1 and itself. So we are removing this 1 and itself. So here we need to check this 2 is factor of this 5 or not. So how to check whether the 2 is factor of this 5 or not? When we divide this 5 by 2, we get the remainder as 0. So here we are applying a modulus operator. If we divide this 5 by 3, we'll get the remainder as a 0. And if we divide this 5 by 4, we'll get the remainder as a 0. So if we get the remainder as a 0, then this 2 is a factor of this 5. So but if we divide this 5 by 2, we'll get the remainder as some 1, and here as some 2, and here also as some 1. So we don't get the remainder as 0. So this 5 is not a from 5 is considered as a prime. So coming to the 6. So if you take the 6 as an input. So if we divide the 6 by 2. So we are not considering 1 and itself, because 1 and itself are the factors of the 6. So we are not considering those 1 and itself numbers. So here we are dividing the number by 2, we will get the remainder as 0. So and we'll divide the number by 3, we'll get the remainder as 0. Here we'll get divide the number by 4, we'll get the remainder as some 2. And we are dividing the number by 5, we'll get the remainder as some 1. So here we are getting the 2 and 3 as a factors of 6. So the 6 is considered as not a prime, and this 5 is a prime. So we are not getting any factors if we divide the number from 1, if we divide the number from 2 to n minus 1. And here if we get any factors, then we are telling it is not a prime number. So consider an example. So here this is the logic to find whether the number is a prime or not. So here we are taking I is equals to 2. This is the for. As per the syntax we are writing the for. This is the initialization, and this is the condition, and this is the modification of the statements, modification of the loop variables. So I we are taking it as 2 because 1 and itself is considered as a factors of that number. So we are not going to consider those 1 and itself. So we are taking the iterations from 2 to n, only from 2 to n minus 1, from 2 to n minus 1. So how we need to check whether the number is a factor or not? We need to divide that number by I. So if we get the remainder as 0, then what we are doing, we are incrementing this count variable. So if we increment that count variable, it is a sign that we have got a factor, and by using this break, we are coming out of that loop. So if you are using that break, if you are coming out of that, if we get by using this break, we are coming out of that loop. If we get one factor or multiple factors, that is not a prime. So after getting any one of the factor, we are coming out, by using this break, we are coming out of the loop. And here we are checking if count is equals to 0, then we are telling it is prime, else we are telling it is not a prime. So we'll do the iterations here. In the first iteration, I is equals to 2 and 2 less than 6. And 2 less than 6, we are taking the input as a 6. And here in the first step in the for loop, what we have written is we are finding whether we got the fact, that 2 is a factor or not. We're checking whether that 2 is a factor or not. So this 6 modulus 2 double equals to 0. So if we divide the 6 by 2, we'll get the answer as 0. So 0 equals to 0, the condition is true. If the condition is true, by using this count plus, the count value is initially equals to 1. Initially the count value is 0. Now we are getting the count value as 1. And the next statement is break. By using that break, we are coming out of the loop. So here we have written count is equals to 0. But the count value we have got it as, the count value it is 1. So count value here it is 1. 1 double equals to 0. Yes, the condition is false. So if the condition is false, it will come to the printf statement, and we are telling it is not a prime. And coming to the 5. If you take the input as 5, we are taking I is equals to 2 and 2 less than 5. Yes, the condition is true. So if it is true, we are checking whether this 2 is a factor of this 5 or not. So for that, 5 modulus 2 is equals to 0 is the condition. So if we divide this 5 by 2, we'll get the remainder as 1. So 1 equals to 0. Yes, it is false. So we are not entering into this block. If the condition is true, then only we are going to enter in this block. If the condition is false, we are not entering into this block. So no other statements in this for after this if. So again, what we are doing by using this modification, we are incrementing the I variable. So this is the first iteration, and this is the second iteration. The second iteration, I will be equals to 3 and 3 less than 5. And here 5 modulus 3. So here the 5 modulus 3, the value is equals to some 2. So 2 double equals to 0, the condition is again false. So again what it happens, again I value will get incremented, and in the third iteration I is equals to 4 and 4 less than 5, yes, the condition is true. So if it is true, again we are checking that 4 is a factor of this 5 or not. So 5 modulus 4. 5 modulus 4 is 1 double equals to 0. If we divide this 5 by 4, we'll get the remainder as 1. So 1 double equals to 0, again the condition is false, and we are coming out of this if. And again I value will get incremented, and in the next iteration I will be equals to 5, and 5 less than 5, the condition is false, and we are coming out of this for. And here then the next statement we have written count double equals to 0. So here the count value, in any of the iteration we didn't increment the count value. So the count value will be is equals to 0, that what the initially we have given. So 0 double equals to 0, yes it is true, and by using this printf statement we are telling it is a prime. The next is a do while statement. So coming to the do while statement, this is the syntax of the do while statement, and this is the flow diagram of the do while statement. So this do while is also used for repeating the statements. The syntax difference is the do, and here by in this brackets we are writing the block of statements that what we want to repeat, and the next after writing the block of statements we are checking the condition. So if the condition is true, then only it will go and repeat the block of statements. If the condition is false, we are coming out of this repetition statements. And here one more important difference for while and do while is, here at least once the statement block will get executed even the condition is false. So as it is an top down approach, so in the top what we have given, that is a do block. So the do block will get executed first, and the next will check the condition, because we have written the condition, we have written this condition after the do block. So at least once even the condition is false, this group of statements will get executed. So one of the example program is the multiplication table. So here in the multiplication table, inside the main function, we are giving the n and I. I is used in the loop variable and n is the input. We are reading the n value, and in the do block we have written the printf statement, that is %d into %d equals to %d. So the n value will be reflected in the first format specifier, the second I value will be reflected in the second format specifier, and n into I value will be reflected in the third format specifier. As we given, for example, if we given the input as 2, so we want the 2 multiplication table, that is 2 into 1 is equals to 2 and 2 into 2 is equals to 4. So this is the output that we want, that we require till 10. So 2 into 10 is equals to 20. So this is a multiplication table we require, that is our task. So for that, in the do block statements we are writing what are the statements should get repeated. The do block statement we are writing what are the statements should get repeated, and here itself we are modifying the loop variable, and then we are checking for the condition. If this condition is true, again we will go to the do block and the statements will get repeated, and if this do block will get repeated until the condition is false. So this is a test case. So if you are giving a 4 as an input, the 4 multiplication table of 4 will get printed, and if you are giving the 34 as an input, the multiplication table of 34 will get printed. We need to set the condition in such a way that if we want till 10 number as a multiplication till 10, so we'll get it as, so we need to set it as I less than or equals to 10. If you want till 20, so at that time we need to set it as I less than or equals to 20. So based on our task, we need to set the condition. So based on that task, the read statement block will get repeated. So the difference between entry controlled and exit controlled loops. So here while is called as entry controlled and do while is called as exit controlled. So while and for, while and also the for are called as entry controlled loops, and do while is called as exit controlled loops. Here the difference is the loop condition has to be initially true for the body to be executed. If the condition is true, then only we are going to enter into the body of the loop. But coming to the do while, loop body will get executed at least once even though the condition is false. So if the condition is false, then the statement block will not be executed even once. But here if the condition is false, then the statement block will get executed at least once. And this is the syntax of this while, and this is the syntax of the do while. Here we have written, here we need to give the condition here, in the while we need to give the condition over here and before the entry of the loop. But coming to the do while, we are giving the condition after the statement block, after we have given the statement block, and here the semicolon is not necessary after the condition, but here the semicolon is necessary after the given condition as per the syntax rule.